Good day, everyone. Before we start, I would like to introduce the members of the group or the reporters for today's topic. And we are, of course, Miss Arabella Bautista and I, Janelle Cleo Anrain and Teresa, and Miss Irene Carl Baquilar, then Ferdelisa Valdez, and Mr. John Blue Malyari. The content of the report are the following: estimating equipment travel time and effects of rolling, grade, altitude, and traction in equipment performance.
Estimating equipment travel time. The cycle time for a piece of equipment is the time it takes to perform one cycle of its planned job. One cycle is basically going to be for a loader is to position itself instead of the area to be excavated or is in front of the soil to be removed. To load the soil in the bucket, to turn around and to move to dump the soil, and then to come back position and get ready for a new cycle. The loading, hauling, excavating, lifting, etc., all of this form is one cycle. Cycle time. Each cycle consists of two components: the fixed cycle part or fixed cycle time and variable components of the cycle time. The fixed time represent those components of cycle time other than travel time. It includes spotting, loading, maneuvering, and dumping. So mostly the fixed time is done where the equipment is in its place and it is not moving. While the variable time represents the travel time required for a unit to haul material to the unloading site and return. It depends on equipment characteristics like the weight and power, the road condition, whether it is flat or bumpy, the grade, which is the slope of the roads, whether it is downhill or uphill, the altitude. The higher from the sea level you are working, the thinner the air will become, which affect the efficiency of the engine, and the distance traveled. The farther the distance, the longer the variable part of the cycle time.
So, let's proceed with the rolling resistance, on which when we say rolling resistance, it is used to determine the maximum speed of a vehicle in a specific situation. Like for example, a vehicle take the circular turn on a horizontal flat rough road. The resistance that a vehicle in traveling over surface is made up of two components, and those are rolling resistance, on which the force restraining the motion when a body rolls on a surface. Rolling resistance, often referred to as rolling friction or rolling drag. It is mostly brought about by non-elastic effects, meaning that not all of the energy required to compress the wheel, roadbed, and others. It is recovered when the pressure is released. Then, the grade resistance, the most basic type of resistance. The force pulling on the vehicle called gravity, especially when a gradient is present. This force could not be perfectly parallel to the road surface. Then, to get the total resistance is equals to grade resistance plus rolling resistance. Resistance may be expressed in either kilograms per metric ton or in kilograms. Then, the rolling resistance is primarily due to tire flexing. The sidewalls of a tire flex as it travels down the road, which ultimately produces heat. If the tire has sufficient air pressure to support the weight of the vehicle and its cargo, the heat generated by the flexing sidewalls is negligible and does not harm the tire. And the other one is the penetration of the travel surface or the tire penetration. It is the depth to which the rubber of a tire penetrates a surface and which is measured in meters. The rolling resistance factor for a rubber-tired vehicle equipped with conventional tires moving over a hard, smooth, level surface is equals to 20 kg per metric ton of vehicle weight. For vehicles equipped with radial tires, the rolling resistance factor is equals to 15 kg per metric ton. Then, it increases about 6 kg per metric ton for each 1 centimeter. So, for example, the type of surface is concrete or asphalt. Its rolling resistance for rubber-tired vehicle is 20 kg per metric ton, while for radial tires is 15 kg per metric ton. Then, the rolling resistance factor increases about 6 kg per metric ton for each 1 centimeter of tire penetration. The equation below lets to estimate the rolling resistance, on which rolling resistance factor in kilogram per metric ton is equals to 20 plus 6 times in centimeter of its tire penetration. Then the rolling resistance in kilograms is equals to rolling resistance factor times the vehicle's weight in metric tons. This is the table 4.1, which provides or shows the typical values for the rolling resistance factor in construction situations.
Hello everyone, my name is Irene Makilar, and today my report was about grade resistance. So it represents that component of vehicle weight acts parallel to an inclined surface. Also, when the vehicle is traveling up, the grade resistance is positive, but if it's travel downhill, it's considered as negative. The exact value of the grade resistance may be found by multiplying the vehicle's weight by the sine of the angle that the road surface makes with the horizontal. So, yung formula po, andito na, makikita naman po dyan kay grade resistance. So, for the grades usually encountered in construction, it is sufficiently accurate to use the approximation of equation 4 minus 4. While the effects of grade, the total resistance to movement of a vehicle or the sum of its rolling resistance and grade resistance, it might be expressed in kilogram, or the total resistance equivalent to total resistance actually encountered. Effective grade calculated by equation of 4 minus 7. So the effective grade or the grade percentage was rolling resistance factor. For example, a crawler tractor weight 36 is towing a rubber-tired scraper weighing 45.5 up a grade of 4%. What is the total resistance or the kilogram of the combination if the rolling resistance factor is 50 kg? So, about po sa solution, ganito po paano makuha si rolling resistance or the neglect crawler. Equivalent of 45.5 weight times 50 kg overweight, then cancelled si weight or letter T, equivalent to 2,275 kg, and ayun na po yung equal ni rolling resistance. So, about naman po sa grade resistance or the kilogram, equivalent to vehicle weight times grade resistance factor, then 45 minus 5p. So, grade resistance equivalent to vehicle weight, kilogram times grade, 4 minus 6p. Total vehicle weight is 36 plus 25.5, equivalent to 81.5 T. So, grade resistance equivalent to 81.5 times 1,000 kilogram weight times 0.04. 0.04 po siya po yung 4% kanina. Equivalent to 3,260 kilogram minus 4 minus 6b rather. Then the total resistance is 2,275 plus 3,260. Bali, ipagpa-plus lang po si rolling resistance and grade resistance para makuha si total resistance equivalent to 5,535 kilogram. Then, yun na po si total resistance.
So, good morning everyone. I'm Arabella M. Bautista. For today, we're going to talk about the effects of altitude. All internal combustion engines lose power as their elevation above sea level increases because of the decreased density of air at higher elevations. Engine power decrease approximately 3% for each 305 meters or 1,000 feet of altitude gained. So, higher altitude means less power. Sa mga elevated areas like mountain, iba yung density ng air compared sa lower area. So, due to the lower level of oxygen at higher altitude, it can affect the performance of the equipment. It may lead to inefficient or sluggish engine performance because of less air, especially if the equipment is powered by internal combustion engine. Some engine kasi requires a specific amount of air to function properly, just like internal combustion engine. Yung internal combustion engine kasi, kailangan niya ng air to create hot gases which will do the work, such as moving a piston. So, internal combustion engine is very useful in situation that requires mobility. So, mas mapapabilis yung work and less manpower. Turbocharged engines are more efficient at higher altitude than are naturally aspirated engines and may deliver full rated power up to an altitude of 3,050 meters or 10,000 feet. So, turbocharger is a forced induction device that forces more compressed air and fuel engine. So, more air-fuel mixtures in the cylinder means more power. So, this is what a turbo looks like. When the rating tables are not available, the derating factor obtained by the use of equation 4.8 is sufficiently accurate for estimating the performance of naturally aspired engine. The rating factor is equals to altitude minus 915 asterisk over 102. Asterisk is the substitute maximum altitude for rated performance if known. The percentage of rated power is equals to 100 minus the derating factors.
Good day everyone. My topic is effects of traction. The power available to move a vehicle and its load is expressed as rim pull for wheel vehicles and rover pull for crawler tractors. Okay, rim pull. The pull available at the rim of the driving wheels under rated condition. Also, the power available at the surface of the tires. Okay, yung rim pull po is ito po yung yung mga equipment na gumagamit ng mga gulong na kadalasan pong ginagamit kapag po sa mga concrete surfaces, yun po. Yung rim pull din is siya yung nagre-resist ng forces para makaandar yung isang equipment. Drawbar pull is the power available at the hitch of a crawler tractor operating under standard condition. Okay, ito naman pong drawbar pull, ginagamit po siya kadalasan sa mga soil. Dahil po yung ilalim po ng isang equipment is bakal para mas makapit po siya and hindi siya dumudulas-dulas. Next slide po. Maximum usable pull. Factors affect maximum pull of a vehicles are: letter A. Operation at increased altitude may reduce the maximum pull of a vehicle. Siyempre, pag pataas ng pataas yung isang altitude, mas mahirapan yung isang equipment dahil nga may dala ito. Halimbawa na lang sa ating mga tao, siyempre kapag tayo nag-hiking, siyempre paakyat yun, pataas ng pataas yung altitude. May tendency na mas mahirapan tayo, di ba? Kasi pakit ng pakit, hihingalin tayo. Kagaya rin yun sa isang equipment. Nahihirapan din ang isang equipment pag pataas ng pataas ang isang altitude. Letter B. The maximum traction that can be developed between the driving wheels or trucks and the road surface. Siyempre tayo, pag gumamit tayo ng tamang equipment sa tamang surface, siyempre tama rin ang kakalabasan. Halimbawa na lang nito, kapag yung equipment na may wheels, ginamit natin sa isang concrete, siyempre tama yung kakalabasan nun. At kapag din ang ginamit natin sa drawer pool, ginamit natin siya sa soil, tama rin yung kakalabasan nun. Kasi yun naman talaga yung gamit niya. Yun lang yun. Para naman makuha ang maximum usable pull, kailangan natin i-multiply ang coefficient of traction times weight on drivers. Dito naman makikita natin ng table na typical values of coefficient of traction. Based dito sa table, mas lumalaki ang rubber tires kapag ang types of surface is concrete, mapa-dry man or wet. Mas lumalaki naman ang trucks kapag nasa earth or clay, or when it comes na hindi siya about concrete, ganun yung types niya. So yun lamang po. Thank you.
To estimate the travel time, we have to account for acceleration and deceleration, and not only for the maximum speed of the vehicle. The longer the stretch of the road, the longer the part where you're going to be moving at maximum speed, because you have to accelerate at the beginning and decelerate at the end. But if you are moving in a very short distance, by the time you accelerate, you have to decelerate because you haven't reached the maximum speed of the equipment. But the longer stretch of the road, the longer part with the maximum speed you are going to reach. Using the average speed factor from tables, convert the maximum speed to the average speed. The travel time is obtained by dividing the travel distance by the average speed. Average speed factor applies twice if starting from rest and ending at stop. Example of speed factors for trucks and haulers. If you are moving in 200 feet, you are going to be moving at only 62% of the maximum speed. Whereas, if you are moving at a length of 5,000 feet, you are going to be operating at 96% of the maximum speed. So, if the trucks stop at both ends of a segment, divide the segment length into two parts and determine a speed factor for each part. Example: a wheel tractor is being operated on a soft roadway with tire penetration of 5 inches. The tractor weighs 20 tons. What is the total resistance and effective grade when the tractor is ascending a slope of 4% and the tractor is descending a slope of 6%? Solution: rolling resistance factor equals to 40 plus 30 times tire penetrations. So 40 and 30 is a constant if you are moving on asphalt. So 40 plus 30 times 5 equals to 190 pounds per ton. To get rolling resistance equals to rolling resistance factor times weight. So 190 pounds per ton times 20 tons equals 3,800 pounds. The grade resistance going uphill is equivalent to 0.04 times 20 ton times 2,000 pounds per tons. 0.04 is the ascending slope, while the 20 ton is the tractor weight and 2,000 is the constant. So 0.04 times 20 times 2,000 equals to 1,600 pounds. The grade resistance descending is going to be negative because going uphill is positive and going downhill is negative. So the grade resistance descending is negative 2,400 pounds. The total resistance is equal to rolling resistance plus grade resistance. So in total resistance ascending, we have 3,800 plus 1,600 equals to 5,400 per pound. And descending, we have 3,800 minus 2,400 equals 1,400 pounds. To convert the resistance into effective grade, we're going to divide by the weight of the equipment and the 20 pound per ton for each percent of slope. Ascending of the effective grade is 5,400 over 20 plus 20. That given is effective grade of 13.5%. So descending of the effective grade is 1,400 over 20 times 20 equals 3.5%.